Hello class, I'm going to just work this lab from your operating systems and you becoming a power user in Coursera. This is part of the Google IT Support Pro certificate. We're on week 4, we're on the assignment partition and format a disk drive in Linux. All right, so get that started here. We're going to read the honor code. We're going to start the lab. I'm not a robot. All right, we have our IP address and username. To connect to our virtual machine, we're going to download the PPK file. Gonna save that. All right, then we're going to start PuTTY. All right, we're going to use our username at our IP address. I'm going to expand it SSH. I'm going to click on auth AUTH. I'm going to browse for my PPK file. And then I'm going to click open. I'm going to say yes. All right, here we are. We are in our virtual machine. All right, our instructions start with blocks and partitions. All right, so before we get into here, let's just talk a little bit about these particular terms. Blocks are a layer of storage devices that allow individual access to independently. That they allow programs to access storage without worrying about whether the underlying device is a hard drive, a solid state drive, or a flash drive, etc. So pretty liberating. It allows you to use storage media how you need to without worrying about what type it is. In Linux, you can view blocks, devices, and file systems attached to your system using the lsblock command. This command gathers information about all devices attached to the system and prints them out using a tree-like structure. To view the devices attached to your VM, which is our machine we connected to, use the lsblock command. All right, so we're going to type lsblk, press enter, and it lists them out in a tree-like structure. You can actually see the sizes of the blocks on here. Very good. All right, just going to go further and explain. You'll see that your instance has 2 block devices attached to it. Each of them, it says 2 that are disks. So if we go back and look, you can see that the type area here, you got a disk and a disk. Each of them is 10 gigabit in size. The column mount point shows where the block device is mounted. So you see the mount point, and you've got that from its location. In this case, the mount point is displaying the / against SDB, which means the second disk, SDB, is mounted at the root of the Linux file system tree. Thus, the files you're seeing in your system right now are from this disk. The first disk, SDA, which you see up there right underneath the first column name, but it's not mounted. In this lab, you will divide this disk into 2 partitions. All right, so we're actually going to work this lab this way. You can view disk mounted on the on the system using the df command. This command is normally used to display the amount of space available on the file system. It lists all block devices with the available space on them. Use the minus option to display the file sizes. All right, so let's do the df-h on our system. All right, see a little bit different view of the information. We see the actual space available. You see it right here underneath this area. All right. Partitions. Instead of using a storage block as a whole, it's common practice to divide a storage block into different partitions. Partitions can be different sizes and formatted to different file systems. This allows you to use a single storage device for different purposes. You can display partition information using the Fdisk command. You can also use the -L option to list partitions in the block. All right, so let's, it says you can pass a device name to the Fdisk command to list using to the partitions contained in that device. All right, first let's just do the Fdisk -L command, and then we'll pass the device name next. All right, let's do that here. I'm going to clear this to give you full view. All right, there we go. So we can see the type of output that you would get there. It very much matches what the predicted output was or is. To list partitions contained in /dev/stb, pass /stb dev stb to the fdisk command. So now we're going to expand on that command, and we're going to take it a step further. So let's, all right, so we see it from a different, just from the perspective of the dev/stb. Fdisk displays information contained in the partition table where information about partitions are stored. All right, so partitioning with Fdisk. When the Fdisk command is used without options, it provides a menu-driven environment for creating and deleting partitions. It gives us a caution here because this is, you know, actually can mess with the data. So you got to make sure that you have your system backed up. When it's a live system, we're using a lab system, so we don't have to worry about that as much here. Any mistakes we make, we can just restart the lab. But in a real live situation, this would be a very powerful command. Could result in some bad things if you didn't plan it right. Mounting and unmounting mean making devices available or unavailable on a Linux file system. This is accomplished by the commands mount and unmount. Before modifying a disk, you should first unmount it from the system using the unmount command. When modifications on the disk are done, you should mount it back onto the system. All right, so we're going to go here, and we've got the command we're going to use. All right. Here we go. Here's the command. Yeah, we needed to put in the /dev/sda. So let me go back and do that again. All right, here we are at the menu. The first option it wants us to do is, it says, Fdisk will start the interactive mode. You can use M to use help provided by the command. All right, you can use P to show details about the partitions on the disk. So let's try some of these out. We can use M for help, right? We can use P for partitions that are available. And we can enter Q to quit interactive mode when you're finished exploring, which is what we'll do now. All right, so we're just back at our prompt again. All right, creating partitions. You'll now create partitions using Fdisk. You'll partition the second drive into two partitions. One swap partition of size 1 gigabit and another of 9 gigabit. The file system type on the second partition will be in ext4. All right, so we're going to go back and enter the command that we were messing around with before. All right, and at this prompt here, to create a new partition, the command control N is used. However, since all the space on the disk is currently allocated, you'll need to first free up space by deleting the default partition. Use the D command control to delete the default partition. When you use the D command control, Fdisk asks you enter the number of partitions you want to delete. Since you only have one, the default one, Fdisk will automatically delete. Select and delete it to continue. All right, so let's go here. Powerful stuff. We're going to enter a D. All right, one partition's been deleted. This, matches our output. Let's see if we can. Well, anyway, you're now able to create your new partition. Enter the command control for create a new partition, which is N. All right, so we're going to enter an N here. Fdisk will present you with two options to select. Select from P for primary and E for extended or logical partition. Since we want to create the partitions on the actual physical disk, we're going to use P for primary, right? So let's do that. All right, and then it's going to, next you'll need to provide the partition number for the new partition. Since it's a primary partition, it can only be labeled from 1 to 4. It's a good practice to assign partition numbers sequentially. Problems can sometimes arise with certain programs if partitions aren't ordered sequentially. Given the number 1 is the first partition by pressing enter or optionally entering 1. We're going to go ahead and physically enter 1 just because for demonstration purposes, but you can just press enter since it's the default. All right, it's going to ask us for the size we want to put in. You'll need to provide the starting sector memory locations of the partition from where you want to allocate. Press enter to select the default value of 2048. All right, so we're going to, the default tells us right here, 2048, so we're going to enter that. We could have optionally entered that in as well. All right, now we've got the next section. Provide the last sector of the new partition up to where you want to allocate. The difference between the first and last sectors makes up the total size of the partition. So you're doing a little bit of math here, but disk sectors represent units used to measure the size of disk. Each sector stores a fixed amount of data. In lots of hard disks, for example, a sector stores 512 bytes to create the first 1 gigabit partition. Enter 2097200 divided by the original partition by 10. So it wants us to okay. Enter that in. All right, then we come down and we created a new partition 1 of type Linux and of size 1023. All right. Two important things happen here. The partition size is set to 1 gigabit and the partition type is set to Linux. You'll see how to change partition types in the next section. Voila. One partition is now created. You now have to move on to the second one. All right, we're going to use the command control N, and we're going to select P for primary. And we're going to use our next number, which is 2. You can also enter, since it's the default, select the default partition starting sector, which is the next sector from the last partition you allocated. So we can just press enter for the default. All right. Also select the default last sector, which will be the last sector of the remaining disk space. So we can press enter to select the default. And then now we've created a new partition type, partition 2 of type Linux, and a size of 9 gigabit. So excuse me, it's my dog barking. I'll put you on mute just a second. Be right back. All right, guys, I'm back. Sorry. All right, so the second partition is now created. Sweet. Before committing your changes, you'll change the second partition to a different partition type. You'll change the first partition to a type Linux swap type. Enter Command Control T to change the partition type. All right, so here we go. All right, and then the partition that we want to change. Let's see. You can use the Command Control L to view a list of all partitions. So we want to change partition 1, so we're going to enter that here. And we can use a capital L and then list all the partition types. 8.2 changed it to Linux swap, so we see that. Let's find it. So you can see these are listed in hexadecimal numbering. So 8.2 is Linux swap. See that right here. It actually points out that this is the Linux swap Solaris, but because of the space on the columns, some of the characters are truncated, so all you really see is Linux swap /so. You see that? So we're going to enter in 8.2 here. Press enter. All right, change type of partition to Linux to Linux swap Solaris. Very good. Moving on here, the partition, up to this point, you've just been editing the partition table in memory. You can now use the Q command here to quit Fdisk without committing changes to disk. You can also update your partition by using the D and N commands to move and add the new partitions. You can also use the V command here to verify changes before proceeding. So I think we'll do that since it suggests that we do. So we're going to do the V command. Our output matches the predicted output, so we're doing good there. If you're satisfied with the changes you made so far, you can commit them to the disk using the W command. All right, we're going to do that. Fingers crossed. The partition table has been altered. Syncing disk. All right. partition is matching. Congrats, you successfully partitioned the second disk using Fdisk. The second disk device is now made up of two partitions of 1 gig and 9 gig respectively. All right, let's check our progress. All right, we did good there. We're going to move on to the next section. Formatting partitions and using MKFS. All right. Next, you'll create different file systems in the partition you just created. You'll do this by using the MKFS in Linux. Multiple file system types exist, and it's important to know all of them along with the functions they're best suited for. In this lab, you'll format the second partition into ext4, the most widely used Linux file system type. So we got the ls block command. We saw that, that's been introduced before. Start with a clean slate here. Let's go ls block. Format the second partition in your unmounted drive to ext4. So we're going to use this command here. But we're going to insert the SDA2 for the second drive, right? Let's see. All right, so where did we do here? It went through creating file system, 4 blocks, allocating group tables done, writing index in inode tables done, creating journal done, writing super blocks, and file system accounting information done. All right, so we got it. So we're going to go through here and we're going to check our progress. Got it. You can now mount the devs /SDA2 to a location on the file system. And we're going to, let's see, let's edit this. Maybe I should just type it. Let's just go here. The reason I don't like typing this stuff is that my typing situation here is not the best. But all right, so we're going to SDA2. All right, so we show that from now on we're going to be accessing it from this way. So just to see, we're going to do the all right, so you see what we added, the mount point for SDA2, we've got it listed right here. We only had one mounted drive before, now we've got 2. So success. All right, so we're going to check our progress. All right, we're done with that. We're going to keep going. Okay, we got a conclusion that wraps this up for us. And then we got to end our lab. So in this lab, we've gone through the process of creating partitions, formatting them to specific file systems, and mounting them onto accessible locations in Linux. You should continue to practice these commands so that you can become comfortable with using them. Good tip. All right, so we're going to end the lab. We're going to rate this lab with stars. Wait for it. All right, I'm going to give it the number of stars. Give it a comment if you like. I'm going to submit it. All right, we've completed the lab. You want to look for your green check mark. That's it. All right, so I'll have this available for you to view at your leisure. All right, thanks for watching.